Alright class, in today's class we are going to start topic, and the name of this topic is vectors. Alright. First thing, what are vectors? Vectors are physical quantities which requires a magnitude and direction. Alright. Like the quantity you're talking about, displacement, it is an vector quantity. Velocity is a vector quantity, right? The quantity which needs direction as well. Let's suppose that Mr. A is standing on the road, right, on the path. Mr. A is standing. If I ask Mr. A to move 2 steps, the first question appears in mind that where should he needs 2 steps? It is on the right side or on the left side. That is why the direction is mandatory. So those quantities which requires direction are called vector quantities, right? But if you go on the milk shop and buy a milk, you won't say that I need a 2 kilo milk on the right direction, right? It does not need any requirement of the direction. So those quantities which do not need a direction are called scalar quantities, and those which needs a direction are called vector quantities. So that is the basic difference, and we are going to focus on vectors, not on the scalars. Alright. How you define the vector? We define a vector by an arrow. Let's suppose that we have written a vector here and it's A and B. Alright. So we are going to say that it's vector A, B, and the direction from A to B. That is the direction of A to B, right? Direction is very important in vectors. You need to focus on direction on every question you are going to attempt. If I am going to draw another vector with the same labels of AB, but this time I am going to reverse the direction. Now it is moving from B to A. Alright. So how I am going to write that? I am going to say that it will be BA with this direction. Alright. So these two vectors AB and BA, they are called negative vectors. And what are negative vectors? Negative vectors are those which have same magnitude but opposite direction. That is negative vector. Alright, same magnitude but opposite direction. And magnitude means, let's suppose the length of AB is 5. So the length of BA, it will be 5, but it will be negative 5 due to the sign, negative sign because of the direction. Alright, so vectors are quantities which require magnitude and direction, and we define the vector by an arrow here. The second working formula, or second important thing, is how you are going to find out the magnitude of a vector. The working formula to find out the magnitude is under root of x square plus y square. Alright. How we are going to apply this working formula? We are going to discuss the working formula for the magnitude and how to define the vector as well from the examples of your book. We are going to deal with the column vector, and column vectors are very important. At first I am going to tell you about the concepts of these basic terms, and then we are going to attempt the examples from the book. So column vector is what we need to define. We can define any vector in terms of x and y. So that is the representation of column vector, right? And it's quite easy to add the column vectors. It is very much similar that you have done in the topic matrices, right? So let's suppose that you have a vector and the value is 2 and 3. So what is 2 and 3 represents here? So let's suppose if I draw the roughly sketch here, right? The 2 is basically shows the position of x-axis, right? So I'm saying that it's 1 and it's 2. 3 is what? 1, 2 and 3. So 2 and 3 is basically this point, and the vector is, this is your vector 2 and 3. 2 on x-axis and 3 on your y-axis. So let's suppose if I'm writing it is at OA, so this is your vector OA here. Alright, so keep in mind the first position represents the value for x and the second one represents the value for y. Before I'm going to proceed further, you need to write down the important points in your notebook and give a time of 90 seconds to start. Alright class, now what we had discussed, we need to apply it in an example, and I have picked one example from the book. It's your new book, by the way, new book of additional mathematics now. You can observe that we have a vector p and q. It says write pq in the form of ai plus bj. Basically, ia represents the x-axis and j represents the y-axis, right? From p to q, we can observe that we need to go 1, 2. 2 steps on the negative y, right? And for x-axis, that is your x-axis path, right? How many blocks are there? It's 1, 2, 3, 4. We need to move 4 units on an x-axis and negative 2. Why it's negative 2? Because we are moving downwards, right? We can say that PQ is equals to, on x-axis we have 4 units, on y-axis we have minus 2 units, right? Or in terms of AI, we can say that PQ is equals to 4i minus 2j. Alright, so you need to follow the path. The direction is very important. It's downward, right? We are moving from P to Q, not from Q to P. So that is the vector PQ. And if you talk about the magnitude of vector, so P magnitude, that is the way we present magnitude. The working formula we had discussed is under root of x square plus y square. The value of x is 4 and y is minus 2. 4 square is 16 and minus 2 square is 4. 16 plus 4, it's root 20. And root 20 can be written in the form of 5 into 4. 4 outside the root, it will be 2 under root 5, and that is your answer. Alright, so you must know that how to write down the vectors if you have an arrow given, right? So just you need to find out the coordinates on x and y, but make sure that you are focusing on the direction. Direction is very important, beta. Alright, so after that, one more concept, and it's unit vector. What is unit vector? Vector which has magnitude equals to 1 are called unit vector. Alright, so all those vectors which have one magnitude are called unit vector. And the representation of unit vector is vector with a cap sign. The working formula is vector divided by its magnitude. That is the representation of a unit vector. That vector divided by its magnitude is the working formula. With the concept of unit vector, we need to attempt an example here to understand the concept, to understand the working formula. We have vector EF, it's 4i plus 3j. Find the unit vector in the direction of EF. For EF unit vector, we need to find out the magnitude of EF, and the working formula for magnitude is under root of x square plus y square. The x value is 4, the y value is 3. 4 square it's 16 and 3 square is 9. 25 and 25 root is 5. So that is your vector, right? And now the unit vector, so I can say that the unit vector of EF is equals to vector. Vector EF is 4i plus 3j. Vector divided by its magnitude, so that is the answer of unit vector. Alright class, so first you need to write down this unit vector in your notebooks, right? and for that part you have a time of 50 seconds because that is very important unit vector. So start. Alright. After unit vector, we need to attempt some of the book questions as we had discussed about how to define the vector and how to find the magnitude of vector. Now, it's exercise 13.1 from your new book. Alright, from your new book. It says write the vector in the form of ai plus bj as we had discussed previously. So I will show you the first part and the remaining parts you need to do it by yourself. So listen carefully. We are talking about AB here. Alright. So I need to go from A to point B, right? And if I need to go from A to B, on y-axis I'm going to move how many steps we need to count it. So it's 1, 2 and 3. On y-axis I am moving 3 steps, but it's minus 3, right? And on x-axis I have moved only 1 step, but it's positive x. So we can say that it's 1i minus 3j. That is your answer for AB. Alright, I hope that it is clear to you. Simply you need to note down the steps you are moving in the y-axis or in the x-axis. Make sure that you are focusing on the direction. Alright class, so with the same approach you need to attempt, I am marking down, you need to attempt AD, you need to attempt BE, you need to attempt HB and you need to attempt DC. So for these 4 parts we have a time of 2 minutes. So give it a try, start, and then I will tell you the answer. So begin. Alright class, if you talk about the part AD, for part AD I need to go 1 step in the negative y. That means minus j, and on x-axis it's 1, 2, 3, 4. That will be 4i minus j, that is your AD. For B to E, starting from B to E, so 1 step on x-axis, that means I, and 1, 2, 3. 3 steps positive on y-axis, that means 3j. Alright class? After that it's DB. From D to B, how many steps on x-axis? It's 1, 2, 3. 3 steps means minus 3i because we are moving in the negative x-axis, right? And for y-axis we need to move 2 steps, so minus 3i minus 2j. And for the last one, that is D to C. For D to C, 1 step negative x, negative y, 1 step negative x. So that means minus I minus j. So these are your 4 answers. I hope that you are getting the same values. After this part, moving on to the next one, it's question number 2. And in this question we need to find out the magnitude. Find the magnitude of each of these vectors, right? So for the first part, the working formula to find out the magnitude of any vector is under root of x square plus y square, right? X is basically the I and y is basically j. So if it says minus 2i, I am saying that it's written minus 2i plus 0j. The working formula is under root I square plus j square. That means minus 2i and 0. So the answer will be 2, right? Minus 2 square is 4 and root 4 it's 2. So that is your answer for the first part, right? So we are not going to attempt all of the parts because they are quite easy. You need to attempt part C, E and G. And for these 3 parts we have a time of 90 seconds, so start. Alright class. For part C, the working formula is under root x square plus y square, so x square is 25 plus. Now minus 12 square is 144. Keep in mind that minus 12 square is not negative 144, that will be positive 144, right? 25 plus what 44 is 169. After under root it will be 13. For part E, 7 square is 49 plus 24 square is 576, right? So 576 plus 49 and root of it leads to 25. For part G here, it's negative 4 square, that means 16, plus 4 square is 16 under root, so it's 32 under root, and root 32, it's 5.65. So that is your answer. I hope that you are getting the same values. Not very difficult question, easy part it is, and we know very well that how to find the magnitude by using the working formula of under root x square plus y square. After solving these basic concepts here, so now we are going to study how we are going to add vectors, right? Addition of vectors. So for the first one, let's suppose that we are dealing with column vectors. Alright, let's suppose that you have a vector 2, 5, and you need to add 2, 5 with 7 and minus 9. So when you need to add column vectors, it's very simple, like matrices. 2 plus 7, it's 9. 5 minus 9, it's negative 4. That is your answer. So addition of vectors, column vectors, that is quite easy. Second one, if you need to add vectors graphically, let's suppose that I have a vector A in this direction and I have vector B in this direction. I need to add these two vectors. So it's very simple. You need to construct the first vector. Let's suppose I'm constructing vector A first, and where the vector ends, we need to start vector B from the same point. So that is my vector B, and the resultant, it will be the missing part. So you need to complete the triangle here, right? So that part here, it's A plus B, and this method is called triangular law of vector addition, because you observe that we end up by making a triangle. If we need to add, let's suppose another example, let's suppose that this vector we have, it's P, and this one we have, it's Q. We need to add these two vectors. So the first vector we are going to plot, it's P, right? That is my vector P here, and the end, from where it ends, we are going to start vector Q here. So that is my vector Q, and the resultant is always the missing part of the triangle. So that vector is P plus Q. Alright, so addition of vector by graphically is very simple. What you need to do is draw the first vector, and where it ends, you need to start the second vector from this point, and to make complete the triangle, the resultant will be always the missing part here. Alright, I hope that it is clear to you. And when you have alphabets, right, let's suppose I need to add xy plus yz. If the alphabets are there, so make sure that these two alphabets must be same. If they are same, then the resultant will be the first and the last one. That is exact. The first and the last one exact. So that is your answer. So to add the vectors, we need to highlight the case first. Either we are dealing with the column vectors, we are dealing with the graphically method, or the alphabetically vectors are present. So whatever the vectors are, you need to apply the method accordingly. Alright, now I'm going to attempt one of the book example, but before that, let's suppose that if you have a vector OA and the values are 2 and 1. What do you think the vector 3OA will be? It will be very simple. You need to multiply the vector OA by 3, so that will be 6 and 3, right? With the same concept, we can attempt this example here. It's worked example 3. A is minus 2i plus 3j, B is 4i minus j, and C is minus 22i plus 18j. Find alpha and mu, lambda and mu, such that it's lambda A plus mu B equals to C. So what you need to do here, you need to place the vector A here, place the vector B here, place the vector C here, and then try to solve the equation. First give it a try here, and you have a time of 2 minutes, and then I'll tell you the answers. So start. Alright, so now it's alpha A is what? It's minus 2i plus 3j plus mu. B is what? 4i minus j is equals to C is what? Minus 22i plus 18j. Alright, now we need to multiply. So that will be minus 2 lambda I plus 3 lambda j plus 4 mu I minus mu j is equals to minus 22i plus 18j. Alright, now I'm going to gather all the I elements. So we have I here and we have I here, right? So it will be minus 2 lambda I plus 4 mu I. Similarly, I am going to gather j terms. 3 lambda j minus mu j is equals to minus 22i plus 18j. I'm going to take common here. So common is what? Common is I here, right? And inside the bracket it will be minus 2 lambda plus 4 mu. Similarly, I'm going to common j here. So inside the bracket it's 3 lambda minus mu is equals to minus 22i plus 18j. Alright, after this step we are going to start with comparing coefficients. Alright, so first I'm going to start with I here and I here. On my left side the coefficient of I is minus 2 lambda plus 4 mu. On the right side it's minus 22. I can divide the whole equation by 2, so that is minus lambda plus 2 mu equals to minus 11, and that is my first equation. For next equation it's 3 lambda minus mu is equals to 18. So that is my second equation. You got two equations and you have two unknowns. Solve them simultaneously and you will get the value of lambda and mu. Alright. You have a time of 3 minutes to solve the equation simultaneously and tell me the answer of lambda and mu, so start. Alright, I hope that you had done it. So the first equation I have, it's 2 mu and lambda only. I'm going to multiply the second equation by 2. Alright, so it will be 2 mu minus lambda equals to minus 11, and if I multiply the whole equation by 2, that will be minus 2 mu plus 6 lambda is equals to 36, and I will place the same equation here. Minus 2 mu plus 6 lambda is equals to 36, and the reason that I multiply the equation by 2 so that the coefficient of mu will be same, I can solve it, right? So 2 mu and minus 2 mu cancel. 6 minus 1, it's 5 lambda is equals to 36 minus 11, it's 25, and you got the value for lambda is equals to 5. Once you got the value of lambda, we can easily find the value of mu. So I can use any equation here. I'm going to use the first one. It's 2 mu is equals to minus 11. When you shift minus lambda on the right side, it will be plus lambda, and the value for lambda it's 5. So minus 11 plus 5, it's minus 6. 2 is multiplying, it will be divide. The value is mu, it's negative 3, and that is your answer. So I hope that the values you are getting are same. Alpha is equals to 5 and mu is equals to minus 3. These are the two values we need to find out, and the question is easily solved by simultaneous equation. Alright, I hope that you got the concept. And I think that it is quite enough for today class, and what you need to do as a homework, you need to attempt the remaining parts of question number 2. Alright, these are the 4 parts that are left, and you need to attempt these 4 parts as a homework. and inshallah in next class we are going to continue the topic. Make sure that before conducting the next session you need to go through all the things that we had discussed, starting from what are vectors till how to add the vectors. Alright, so if you don't have that new book, so just drop me a message on the portal and I will upload the pages from that book, so you can easily access that pages for your homework or for your guidance, right? So